that particular student. So keys enforce entity integrity and establish relationship between tables. So we use that to make a lot of links. So over here, these are the types of keys, and this is the hierarchy. We have the super key on top, then we have the candidate key, then we have the primary. Out of the candidate key, we have the primary key and the foreign key. So with this, super key is any combination. So up here in the table that we have, I can combine student ID, which is the primary key, plus any of the following columns. I mean, I can say student ID, I combine student ID plus the name. That will give me a super key. So a super key is the product as the primary key plus any other key. It could be one or more. So that is super key. So that's why over here you are seeing that super key is any unique combination. And by this, you make sure that that particular column that you are selecting to be part of the super key, it should be unique. It should have a unique, numbers. So example, like if we were supposed to have a national ID in as part of the columns, then we can use the student ID, which is the primary key, plus the the national ID of that student, because the national ID is unique. Everybody has a unique national ID. So when we combine these two, then we'll have a super key. So from super key, then we have what we call the candidate key. So the candidate key is just one of them. So the candidate key can just be a primary key, or it could be a foreign key. So when we say the primary key, that means that in that table, there should be a unique key to identify each of the rows. So then that's what we say primary key. But if we say foreign key, that means that you have a primary key that goes into another table's row. You have another table and you link that you understand this as you go deeper. So this is a super key. So a set of attributes, one or more, that uniquely identifies a tuple may contain extraneous attributes. So over here is giving us an example like the student ID, which this is very unique. We have the name, phone. Then we also have student ID. Then we also have the name and phone. So just a combination of any two of them should give us what we call the super key. Then the candidate key, as I said, should be at least one thing. That's the smallest set of attributes that can uniquely identify a tuple or a row. So that's the student ID, only one. Then, and the primary key. So this is the chosen candidate key that uniquely identifies every tuple in a relation. So it is the principal identifier. Okay. So now, what are some of the properties of a primary key? It should be unique. It should be minimal. It shouldn't be null. It shouldn't be null. Sorry. It's not null. That means that there should be a value. You can't leave it as it is. There should be a value. It can't be empty because we want it to uniquely identify a row. If you leave it empty, no, it's wrong. There should be a value. So when we are creating, we set it to not now. That means it shouldn't be empty. There should be a value in it. And the primary key should be stable. The primary key value should rarely or never change. Shouldn't change at all. So uniqueness that no two rows can have the same primary key. No. Minimality, no proper subset of the primary key can uniquely identify tuples anyway. So what is important here is, like, unlike other keys, only one primary key exists per table. So every table will have one primary key. So example, in the student database, the student ID serves as a primary key because each student has a unique ID. Name alone can't be a primary key because multiple students might have the same name. You can have Don Mensa, about 5 Don Mensa. So that's why we can't use only the name. But in super keys, if we combine that one with a unique key like the student ID, then you can classify them as super keys. So as I said earlier on, the foreign key is an attribute in one table that references the primary key of another table. So this is used to establish a relationship between the table. So the purpose of the foreign key is to enforce referential integrity, to create links between two tables or two or more tables, and to allow joins. So with that, we're able to join. So as you can see the picture here, we have the student. This is a primary. We have the enrollment. So over here, student ID and name. And over here, we have the enrollment ID, student ID. So over here, we have the student ID as the primary key here. But when we come here, the student ID becomes a foreign key because we're about foreign land. So it becomes a foreign key in a different table. And this helps to link these two tables so that you can query that, oh, you want the enrollment details of maybe this student S001 Akua. When you query that like that, it will give you the E001, then also to give you the course that student is doing. So that is the foreign key. So let's see some key comparison of what we've mentioned so far. So in the keys, we have the primary key, the foreign key. So primary key can be null. No. Primary key, as we said, it can never be null. Multiple per tables, we said no. Only one primary key per table because a unique identifier. And for foreign key can be null. Yes, it can be null. It can be in multiple tables. Yes. So this will link to another table. Candidate key, which can either be so candidate key is more of any unique key. So that could be a primary key and also not a primary key anyway. It could also be a foreign. That's why we have no here because it can be primary key, which it can't be now. So no, then you can use multiple table. Yes, potential. Yes. So yes, you can just continue and you should understand this. So remember, the primary key is equal. So that's just for you, only one, and must not be now. Then also foreign key can be this and that. Yeah. Okay. Good. So let's see some of the constraints. So we have constraint. We call constraints. So constraint is more like how do you call it? It's like I say limitation. You are limiting. Now putting limitation on this on your rule. So constraints are rules enforced on data to ensure accuracy, consistency, and integrity of the database. So that's the benefits. So that's the benefit of having constraints, and we'll understand this as we move on. So we have types of constraints. We have the key constraints. So if you hear the word key constraint, that means your mind should go to the keys that we made mention. Then we have what we call the entity integrity constraints. We have the referential integrity constraint, which is also known as the foreign key. Then we have the domain. As I said, the domain defines that record should, have a specific data type. It shouldn't have a different. It should have a specific, and it should work within a certain range. That's what we define by the domain. So we have what we call the functional dependencies. So a functional dependency denotes that X is to Y exists when the value of the attribute X determines the value of Y. We say X functionally determines Y. So that means Y is dependent upon X. Y depends on X. So we say that X is a determinant. So X would determine what Y should actually do. So the notation A to B reads like A determines B, or B is functionally dependent on A. Without A, B can't work. So like student ID, we have what? Age, name, and program. So age, name, age, and program, they depend on the student ID. So knowing the student ID will allow us to determine all other attributes of that student.
Sir,
I hope you are
too fast.
yes. I'm going too fast then.
Yes.
Okay, so I'm saying that with the functional dependency, like over here, the student ID, if you see this notation A, then arrow B, that means that B is depending on A. So I'm saying that this notation reads that A determines B. So it means that B has to depend on A. B can't do without A. A will determine the outcome of B. So in other words, we say that B is functionally dependent on A. So an example is the student ID, the student table that we had. We have a student ID in the table. So we're saying that if we know the student ID, we should be able to get the name, the age, and the program of that student. Right? Good.
Yes, sir.
So, what are the types of functional dependencies? So we have full functional dependencies and partial. So, like why? Why depends on the entire composite key. So why we depend totally on A, which we are looking at the student ID and course ID. So I think this is also a different table. So with that table, it has a course details. That's why we're having the course ID and the student table, because course ID table will have a grade. So in order to get a grade, then we need the course ID. Then we need to know the student. So we need to know the student ID. That can help us to know, once it's linked to the course table, then we know the course that the student is doing. And once we know the course that the student is doing, then we're able to know the grade of that course for that student. So the grade will be dependent upon the course, because every course will have a grade. After writing an exam, you get a grade for that course. And a course also goes to a student are enrolled in courses. So each student will have their specific course
I'm not
and
seeing
the
your
grade.
screen.
You are not seeing my screen.
Yes.
Please check your internet because I can see.
Then it's your internet.
Check your internet and we can see it.
Because the voice is clear here.
And so just log out, just sign out and come in
Fine.
again. So the partial says that Y depends on part of a composite key. So with the full, you see that the composite key is the student ID and course ID. Right? Hope you understand. It's a bit technical. Then Y depends partial. Y depends on part of the composite key. So right now, over here, you can see that we have the student ID and the course ID. In the student table, we don't have student name there. The student name is only in the student table, which has the student ID as the primary key. So that's why you're seeing that the student name here, the student ID and course ID maps to the student name. So this is partial because it depends only on one, not the two. But over here, the grade will depend on the course ID and the student name, because you need to know which the course, the grade, maybe it's A, or which course did you get A and which students. I hope we are fine. So from the functional, we have what we call the transitive, the transitive. So transitive, as the name goes, is the movement from one to the other. So we define this as a dependency. A transitive dependency exists when attribute C will depend on attribute B, and attribute B depends on attribute A. So now A maps to C through B. So as we can see the picture here, we have employee ID as A, we have zip code as B, and we have city. So over here, we can't get city without the zip code, because the zip code will determine the city. Each zip code, every city has a unique zip code. And over here, the employee ID in the employee table, we can't know where baby Amma means or Amma or say stays without the employee details. Because over the zip code will just give a lot of codes, keke, without any meaning. So to understand this, then we need to have the employee. So over here, you can see that we have the city Accra, we have the zip code, we have the name, we have so the name you are seeing here is part of the employee table. So we have the employee ID, this, and the name is this person, and there's the zip code. And after the zip code, we're able to get the city. So the zip code is able to only Ghana that I don't know Ghana that we are using 00233. But we can liken that one probably no. So when you go to the states, if you mention a code, they will tell you the particular state, whether it's Virginia, whether it's Georgia, Atlanta, or so to give you the exact location. So that's over here. We made an example like 00250 is Accra. So you can have 002, maybe 252 to mean maybe in Sawum, or maybe we can use that maybe as the cities. So 251 maybe could maybe mean Eastern region, 252 could maybe mean different region, Water, and so on. So we see that the zip code is direct to what we call the employee ID, because the employee ID will help you to determine the zip code. Then likewise, the zip code has one city, that's Accra, and the city depends on the zip code. Therefore, we can say that the employee ID is mapped to city, transitive, because it has to pass through another person, like the city, sorry, like the zip code, to be able to get to the employee ID, to get information about the employee. So there's a problem. So transit depend, that means it can cause anomaly and violate the third normal form, meaning that I need to go to city before. I'm not directly linked to the employee table. I have to go on to another. So assuming that middle person that I'm relying on is not available, that means there'll be a problem. Communication gap. So now we are moving to normalization. This is more technical, so you need to really pay attention. So normalization. So it's a systematic process of decomposing relations. When we say relations is stable, so you can have one table and you have to break the tables into various other tables. You can have one table and you can break it into two tables, or can break it into three tables, because we want to eliminate redundancy and also undesirable characters like insertion, updates, and deletion and anomalies. Please hold on, let me see. The session has been recorded. Okay, good. It's being recorded. Good. I wanted to be sure it's being recorded. Okay. Good. So we have what we call the unnormalized form. So the unnormalized form is when you have that table, you haven't done any normalization to it, then you can change that table to a first normal form. And over here, with the normal form, we look at atomic values. It means that we don't want a record to have, let's say, it should have two or more values. Example. Let's use this table as example. Example, like over here, we are seeing enrollment. Then under enrollment we have course, and the course we are seeing the course ID. Then we have comma the course title. No, if it is course, the course that we have, if it is the ID we are using, it should just be ID. We don't want multiple values within the record. So you understand this. I think there'll be some pictures for you to understand. So with the first one, you need to eliminate that. And usually by eliminating that, when you introduce and when you have a new table, you can just break them. You understand it as you proceed. Then the second talks about no partial dependencies, as we talk about the partial dependencies. Then the third is no transitive. I mean, it shouldn't depend on like A, B, C. It shouldn't A to B, it shouldn't depend on B. Then we have the boys code normal form. That means all on private key. We understand this as we move on. So what is the objective of normalization? You'll be asking, but I say normalization, what is it? What do we want to achieve? One, we want to eliminate redundancy. We don't want, let's say at the hospital setting, you have your name. If there's database, and in the database, your name is let's say your details at the OPD is different from consulting and from pharmacy. So if you have to update your records, maybe you have to update your date of birth or something, or maybe your weight, then that means you have to go to OPD and change it from there. Then you move to the doctor's place, consulting, change from there. Then you move to pharmacy and change from there. So that is what we call the redundancy. But we want to avoid that. We want to make sure that if we change from OPD, automatically it changes at the consulting and also the pharmacy. Then two, to prevent or to minimize anomalies. That is to prevent insertion, deletion, and modification anomalies, as I rightly said. So with redundant data, if you're able to eliminate that, we can save more space and ensure the integrity of your data. So we have three anomalies. One, we have the insertion anomaly, we have the deletion anomaly, and we have the update or modification anomaly, which you can read and you understand. So normal forms, this overview. A normal form is a property of a table or relation that indicates its degree of freedom from redundancy and anomaly. So put this in your mind. It's two. Why we are doing normalization is to eliminate redundancy and also prevent anomalies. Okay. So this table gives you what we eliminate at each of the normal forms. We have the first normal form, we have the second, the third, then we have the boys code normal form, then the fourth normal form. So we realize that over here, it's telling you what we do at that side. Then the key rule is that one, we need only atomic values. Then when it comes to second normal form, full functional dependency. We don't want partial. Then the third will have no transitive dependency, shouldn't depend on any. Then the BCNF says that every determinant is a candidate key. So it could be primary key or any unique key. Then the last one says that no multi-value dependency shouldn't depend solely on certain values and all that. So which will treat them one by one and you appreciate it. So the first normal form, please, let's pay attention. The first normal form. So over here, a relation is in first normal form if and only if it contains only atomic indivisible values. And each attribute contains values from a single domain. You understand this when I do the example for you to see. So one, what are the rules? One, each attribute must contain a single value only. All values in an attribute must be of the same data type. So I told you, if it is int, it should be int, integer. If it is float, it should be float. If it is string, it should be string. Then each attribute must have a unique name. So that means the title should be unique. So I told you attribute is more of the columns, like department ID, like department name, like location. The order of rows and columns does not matter. Okay. And each tuple, that is each row from here, left to right, must be unique, no duplicates. Okay, so look at this. Before we do the first normal form, you see we have what? The department ID 001, we have the department name, finance, and we have location. So over here, location, you see we are seeing Kumasi and Accra. So this one goes against the first one. The first one says it must have a unique or single value only, but we are seeing two values, Kumasi and Accra. So we'll see the problem is multiple values in location attributes. So that is wrong. So then we need to eliminate this. So to do this, that means we need to create another. So over here, you can see that we have one value per cell. We don't have Kumasi Accra anymore. So by this, we have to create another rule for this. Another rule for this. But we are trying to avoid a situation whereby a table should have the unique number should be more than one. No, we want to have one. So even though, yes, we've solved the first part of it, which says that it should have a single value only, that also creates another problem. So that will also push us to the next one, which is the second normalization form. I hope you understand, please. I hope you understand.
Yes, sir.
Good. Okay. So let's look at the second. So the second is a relation. A relation is in second if and only if, first of all, it is in first normal form. That means we've done the first approach. And yes, what's up there? We've done the first approach. Then secondly, every non-prime attribute is fully functionally dependent on the entire primary key. There shouldn't be any partial dependencies, as we said. So over here, let's see what we have here. So second normal normal form only applies to relations with composite, that is multiple attributes, primary keys. So where we can see that the primary key is teacher. Is teacher, right? And teacher, we have subjects and what we call teacher name. But over here, see the subjects. Because teacher ID, teacher name, we know it's in order. We have, because the teacher's table should have the ID and we should know the name of the teacher. But the subject here is kind of foreign. It's kind of foreign. So we're having the primary key being the teacher ID and the subject, and that is a composite. So then we need to break these two. So teacher name depends only on the teacher ID, not on the subject. So it becomes a partial dependencies. If you remember, when we're talking about the partial dependencies, we said that it should only be full for second normal, it should only full dependency, full. But over here, we can see that we have the subject. And now the subject, it has nothing to do with Mr. Kofi, the teacher's name. Even though we know that the teacher teaches a particular subject. So over here, you can see that the teacher name is only linked up to the teacher ID, because the teacher ID should give us the teacher's name. When you come to the second normalization, when we apply, then that means we need to have another table. So one table with teacher, and that will have the teacher ID and the teacher name. Then another table should have teachers. So teachers mean that that every teacher will have a link of the teacher detail and that of the subject that the teacher will teach. So that's why we have the teacher ID and the subject. So we can have just the ID like T001, then the subject that the teacher will teach, like math. Then the teacher will have the teacher ID in the teacher name. So then that means we have to be, so normalization is more of breaking that whole thing into various tables so that it will ensure consistency. We will eliminate redundancies and also reduce anomalies. Are we okay? I want to be sure you're okay before I move, because we are building up on it as we move.
Yes, sir.
Okay, good. Then let's go to the third. The third normal form. So definition says that is a relation is in third normal form if and only if it is in the second. That means the second also will say that if it is in first, so it means that you need to do the first, the second before you can qualify to do this. So over here it says that no non-prime attribute is transitively dependent on the primary key. So no transitive dependencies. And by this, what do we mean? So alternative, we have the alternative definition is the code. That's the name of the person who actually invented. So a relation is in third normal form if for every non-trivial function dependency X maps to A, that is either X is a super key or A is a primary attribute, part of some candidate key. And some candidate key is, when we say candidate key, that means it's either a primary key or it's a unique key elsewhere. So let's look at this example that will let us understand. So over here, we are saying that this violates the 3NF. So we are seeing employee ID here. We have the name, correct? But we are seeing department and we are seeing head. We are seeing department and also we are seeing what? We are seeing head here. So now that means that the employee ID will map to the department and department to the head. So it means that the head will depend on the department, because without the department, we can't know the head of that department. But over here, we see the department also will definitely will also depend on the employee to know that who belongs to that department. So if you remember that what we did earlier on with the A, B, C, the C was dependent on the B and the B was dependent on A. And now we are saying that we don't need that. We need to avoid that dependency. So over here at the top, we say that X is super key. So now the super key, we have we can have the employment ID or the employee ID, and probably we can have a department name or something. Yeah, department ID. Let me put it that way. You have a department ID because every department will have an ID, department name, and a head of departments. So over here, That means that this one, the department head is dependent on the department name, and that one also depending on the employee, the table. So in order to resolve this issue, then we need to also create another. We also need to create another table. So you see that over here we have two tables. The one table is employee, other table is table. And in the employee table, we have the employee ID, then we have the name, which we had it over here. Then we have the department ID. So the department ID is now a foreign key because it's a primary key in department. So you see that department, we have the department ID, name, and the department head. So the department ID here becomes a foreign key up there. So by this, we've divided this table into two. And we introduce a foreign key, which is the department ID that we can see in the employee ID. Please, are you okay?
Yes, sir.
Are you the only person on call?
No, they are all on call. About 39, 40. We are 40 on call.
Yes,
So
sir.
we are
Hey,
here.
Yes, sir, we are here.
you are there
Yes, we
and you're
are here.
enjoying.
Yes.
Yes, we are here.
But we are
So, but
confused
you
though
see, one
David
because
person
Shatta.
she wants to reply you. So
we
she
are
wants
here,
to
sir.
reply you.
Okay, I understand. Thank you.
It's
Maybe
Sir,
a
you are
Shatta.
going
it's a
too
bit
fast.
complex.
Following.
I'll slow down. Mavis,
Too fast.
Sir,
And
sir.
just explain the one and let's see. Explain this.
Tell me, I can't explain. No, me, I'm following. I can't explain anything. But I'm following. I think I'll have to
Who
go back again.
understands the first normal form? Who understands the first normal form?
Sir, this thing there. Mm.
Please ask the question. Who understands the first normal form? Nobody understands.
So we understand, but how to explain the way you are explaining it?
That means you don't understand. Because if you can't explain, that means you don't understand.
Explain it how you
So the
understand.
thing we don't understand. The truth is we don't
No,
understand.
so
Who's
tell
saying
me,
she
just explain to
understands?
me
We
how
don't
you
understand
understand.
the whole thing.
Just explain to me how
Exactly.
you understand. Tombo,
Hello, sir.
explain how you understand this example.
Okay, so we are talking about the table. We are looking at the first example, the one with department ID, department name, and location. So we are saying that they depend on each other. And so when the data is constructed, it makes it difficult to identify. So for us to do the correct thing, we need to create another table which will separate some of the items. This
Okay,
is
I'm coming. Let me come in. So let me come in. So the idea of the first normal form is that we don't want a column to have two or more values. So as we are saying, we can see that locations as Kumasi and Accra, and that is wrong. We don't want that. So in order to get a correct state of it, that means you have to introduce another rule. That is why on the right hand side, you can see that we have Kumasi alone and we have Accra alone, but we have a repetition of the department ID and department name. This is because we are trying to say that the Department of Finance is in Kumasi and Accra. That's what we are trying to say. So in this one, it doesn't want multiple values in a record. We should have Kumasi and Accra on one. I mean, that we should have those two. That's why saying that each attribute must contain atomic, that is single value. So over here, we are seeing double value, Kumasi and Accra. So in order to change this, then that means we have to have another row, another tuple. So that's why over here you are seeing that we have the D001 being 2. the same department, but the location we've split them into two. So because of the location, that's why we have to make them into two. This one too, you don't understand.
So sir,
Hello.
with this one NF, does it mean if the department name is finance and account, let's say finance and account, we can still split it in the next table as D1 finance and then D1 account, and then just the location is maybe Kumasi.
Okay, so as I was saying, if let's say over here, instead of the location, let's say if the location is only Kumasi, then but the department here we have finance, then comma accounting. That
Yes.
means that we have to add another column, but this time around we have D001, another one come under, then we have finance on top, then we have accounting down, then we have Kumasi.
Yes, sir.
Yubab. So assuming we have another one that says that finance / accounting, then location we have Kumasi and Accra. That means we are going to have about 4 of the rows. So that we have finance Kumasi, then we can have finance Accra, then we can have accounting Kumasi, then we can have accounting Accra. Yubab.
Yes, sir. I get it.
So are we all okay?
It's better,
Yes,
sir.
sir.
Yes, please.
The network
Okay.
is very, very bad at my end.
That one there, I can't help you. That one there. Okay.
Bye bye.
So the same way we talked about the second normal form, and we are saying that in order to do a second normal form, one, you need to do the first normal. So the second will depend on the first. So if you haven't done the first normal form, you can't do the second, because the second will make sure that you have to be in that state of first normal form before you can change. Okay. So over here we use example of a teacher subject thing details, and we are saying that we have a teacher ID here and we have a subject here, but we all know that the teacher table will have teacher ID and the teacher name. We don't have subjects. So to have a subject, that means there was an introduction of a different key. So in order to resolve this issue also, that means we need to split this into 2 tables. And to split into 2 tables, we have the teacher table as we are seeing there. And the teacher table has teacher ID and the teacher name. So another table that we created was teachers. That's the name of the teachers. So then that table, also we have the teacher ID and the subjects. So that it means that we've linked the teacher to the teachers table using the teacher ID. That's why we are seeing teacher ID here and teacher ID in teachers table as well. So that you can know, okay, Mr. Kofi teaches maths. So that's why you can see that teacher Kofi, then teacher's name, teaches maths. I hope you understand now. So the second one, we are talking about the partial dependencies. We want full. We don't want partial. So we have to eliminate that one, because it depends solely on the teacher's ID and not the subject. So you can see that the primary key, that's the composite key here, we have what we call the teacher ID and the subject. But the teacher name depends only on the teacher ID, not the subject. So that means it's a partial. If it was dependent upon the 2, that's when it will become a full. But it's dependent only on the teacher ID. So that's what we are saying is partial dependency, because it's dependent on it only partially, only that of the teacher's ID. So then we have to decompose them into separate tables. And by doing that, we introduce a new table we call teachers. So that's why we have a teacher table that says the teacher ID, then we have the teacher name. Then we have what the teacher actually teaches. And we are linking that one to what we call the teacher ID. So teacher ID here, then it shows the relationship. I hope we understand this. Okay.
Sir,
So let's
please
move
go
on.
to
So
sir, please go to the second NF. So with this diagram, what you're trying to say is that if you have created a database and you type in the teacher's ID for the first one, the one in red, it means that when you type the teacher's ID, you are only going to get the teacher's name. But this time around, when you link it and like to the second one, that is the complies with the second NF. It means that when you link it, when you type the teacher's ID, you are going to get the teacher's name and then the subject he teaches. Is that it?
Yes, because that there's a link, there's a relationship.
Okay, but with the first one, there's no relationship.
Because
It's
you've
only
linked
the
the
name
two
that will
tables.
come.
Exactly. So that means that the subject there will be redundant.
Okay.
You've created space bar, right?
Okay.
So we are saying that we have to normalize it so that to ensure consistency, to eliminate redundancy. You Bob.
Yes, sir, I get you, sir.
So can I move on?
Yes, sir.
So in the third one, we are saying that to do the third one, you need to make sure you've done the second normal form. And with this, we are saying that X has to be a super key, or A is a primary attribute of some candidate key. So when we're saying some candidate key, that means that it can be a primary key in another. That's where we bring in the foreign key thing. So we are saying that we're given this year. And as I use the example of ABC, A maps to B and B maps to C, means that C depends on B and B depends on A. And with this, the third one, we don't want that. We don't want C to depend on B. Then, as well, if B is not there, then how do we reach out to A? We can't. So then, that is why over here, to do that, then we have to introduce another table because we have employee. For employee table, we have the employee ID and then the name. Then now we need to have another table for department name and the department head. So that's why after normalizing it to the third, we are seeing that we have the employee table, we have the employee ID, we have the name, and there is an extra attribute which we call the department ID. And why do we have it there? Because we are linking the employee and the department table together so that you can find, if you want to look for maybe this employee Ekua in a department, I want to know if you want to know simple, you want to know the head of department for the employee Ekua. We know that employee Ekua is in the finance department. And being the finance department, his boss is what? Is Kweku. So over here, we separated the tables. We have two tables, and we introduced what we call a foreign key. And the foreign key in the department ID is a primary key. And this primary key is part of what we call the candidate key. So the primary key now, it becomes a foreign key in the new table that we created. So this will link this together. And as my brother was saying, so that means that if we need information, you can just stand here and pick the employee, and we can get, once you get an employee, you can get every information relating to the employee. You can get employee department, you can get employee head. So by this, we are saying that we are not, the head of department is not depending on this employee name. Because over here, once we have the department ID, all this information we have access to it. I hope you understand. Okay. So the BCNF. So it's a relation is in BCNF if and only if every non-trivial functional dependency, that is X maps to Y, and X is a what? Super key. We told that super key is that X being having a primary key and another unique entities. That will make it a super key. So we are saying that BCNF is straighter than 3NF. Every relation or every table in BCN is also in 3NF, but not vice versa. Every table in BCNF is also in the 3NF. So let's see this. So requirements. 3NF requires that X maps to A, where X is a prime attribute, which we're talking about the candidate's key. With the BCNF requirement says that all dependencies must have X as super key. That means every dependency, if I depend on somebody, should have a super key. And over here, 3NF requirements say that it's more permissive, but the BCNF is stricter. It eliminates more redundancy. Okay, so we understand this. I need to get an example. Let me see. Okay, so we are comparing the BCNF versus the 3NF case. So say that consider student ID, course ID, and this maps to instructor, and instructor also maps to course ID because instructor teaches a course. So this is in B3F, but not in BCNF because instructor determines course ID, but instructor is not a super key. So over here, I think I will need more graphical things for you to really understand. Because I know some people are more of graphics. So let me see. Okay. Let me see. Can you see my screen? What do you see?
Yes,
Yes,
please.
sir.
Google search.
What do you see? Good.
You are searching something in Google.
For you, yes. So you see over here we have this table. And per this table, we're having students, we're having teacher, we're having subjects. So even just per this, you know that we can have 3 tables. Because you can have a student table that will have a student ID in it, the student's name. Then we can have a teacher table where we can have the teacher's ID, the teacher's name. We can have a subject table where we have subject ID and the name of the subject, right? Are we okay with that?
Yes, sir.
Hello.
Yes,
Yes.
sir.
So over here we can see that teacher students, okay, they map to subject because students is taught by a teacher and the teacher teaches a particular subject. Okay, then with the subject 2, we have a student offering the subject, we have student subject because a student will study a subject. Then so you can see that we are having composite keys here. We have the student, the teacher, and over here we have the student subject. Then over here we have the teacher, which teaches a subject. So let's go down. So the candidate keys here are what we call the student teacher. Then we have the student subject. So the above relation in the 3N, since there is no transitive dependency, a relation R is in blah 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 blah. So the above relation is not in BCN because in the full dependency, that is teacher subject, because teacher will teach a subject and subject is always dependent on the teacher. because the teacher will teach that subject, and teacher is not a key. So this relation will suffer some anomaly. So, for example, so that's what they've done. They have to split this into two. So if we delete the teacher, the student Tahiru, if we delete the student Tahiru from here, we also lose the information. I'm coming, wait. So if we delete students, those are the students. Tahiru. If let's say we are going to delete this, if we delete the student Tahiru, we will also lose the information on this one, N dot Gupta. Because if you are deleting Tahiru, that means this will go off, this one will go off. And by this one going off, that means we are losing another teacher. And the teachers, details and the subjects. So this issue occurs because the teacher is determinant. The teacher itself is the determinant, but not the candidate key. Okay, so let's see how we go by it. So now we divide the R into two. So we have the R1, R2, where we have teacher subjects. So every teacher and the subject that the teacher teaches. Then the R2, we have the students and the teacher who teaches that students. Right? So we can decide to even delete Tahiru. So we did that, still we are going to have two teachers being off. Good. Okay. So now let's see. Let me see if they have more explanation here. So in order to really solve the B, C, N, F, then that means this one too, we need to further break it down. We need to further break down because for this, I think this one is okay. We need to further because over here, if we delete this one, Shanyan, that means we are deleting two teachers, and the same applies here. So then we have to break this one to also further to ensure that deleting one person doesn't delete other information because it's dependent, other information is dependent on the other. So it's all about moving the dependencies. Okay, let me see if there is any other explanations here. Using set becomes very difficult to understand. Okay, let me see this one. Okay, so there's another example. Maybe we can appreciate this one. So right now, see what we have here. We have student branch, student course. So the student branch here, we have the student ID. Branch means, let's say branch means maybe the program. So the students, we have computer science and engineering and electronics and communication engineering. So the candidate key for this table, student ID. That is the student ID. That's the candidate's key. That's the primary key. Yeah. Then over here, the student course table. So we can have the student course. These are the courses. Then the branch number. So branch I told is more of the program. Then the course number. Okay, the course number. So let's see. So over here, student enrollment table will have the student ID, then the course number. So having the course number will let us know even the branch, then even the course. So you can see over here the branch number, we have the same branch number. It means that it's from the same department. Let's use the branch as the department. So we have the same department, but we have these courses that are being run by that one department. So over here, this course is unique. That's why we have 201. Then the computer network has 202. Okay, so over here, the candidate key for this table is what we have the student ID, then we have the student course number. So after decomposing into further table, now it becomes BCNF as it is passing the condition of super key that is in the functional X maps to Y, and X is a super key. So in this case, the X being super key is what we call the student ID here. The student ID is a super key. Okay, so let's see. There's another example here. I think this is more set to. So find the highest normal form of a relation. So the relation is R. I want to find the highest normal form. I think this one will be very difficult to understand. I need more graphical. Okay, let's see if I can get a graphical. Okay. Okay. Let me see. I think I saw a table here. Let me see this one. Let's see if this one will be helpful. Oh, this is just okay, let's see. No. Okay, so that's what I'll do. So with the BNC, I'll give you once we are now give you a material to just explain more of that. So let's move on to the fourth one. The fourth one is a relation. A relation is in the fourth normal form if and only if it is in the BNC. So you realize that when we are moving forward, you need to ensure that it is dependent on the first one. So you see that the second normal form was dependent, will ensure that you are in the state of first normal form. The third normal form will ensure that you are in the state of second normal form. And likewise. So that's how it goes. So over here, it says that relation is in four or the fourth normal form if and only if it is in the boys called normal form and contains no non-trivial multi-value dependencies. So we'll understand this with an example. So a multi-valued dependency exists when a relation has at least three attributes, such that for each value of A, there is a set of values for B, and a set of values for C, and the set of values for B and C are independent. That means they're not on their own. They depend on something. So the notation, this is a notation. A maps to B. So it means that a multi-valued determines B. A multi determines B. So let's see this. This will make us understand. So over here, we have students, course, and sports. Students, Ekua. You can see we have Ekua here. Then we have the courses. And we have what? Sports. So you realize that Ekua, one person, that's this course, maths. Then when you come here to, we have another Ekua doing maths. Here too. So with this one, you can see that we have a lot of let me say redundancies. We have a lot of redundancy because how does sport relate to course? Right? It actually depends on, I mean, students also, yeah, students, because a student will love sports. Let's say maybe that is the game the student likes. So with this, that means we have course on its own. Then we also have what we call the sports on its own. So by this, we need to find a way that we can link them together. So you see the problem. Courses and sports are independent of each other. And they don't depend. So it has nothing to do with it. So in solving it, then we have student course, then we have student sports. So that we can have student course, the student and the course, then we can have the student and the sports. So per this, let me see if I can use Excel to just show you the outcome of what you are seeing on the screen. Please, do you see my Excel? Please, do you see the Excel sheet?
Not yet,
No,
sir.
sir.
No, sir. We are seeing the presentation.
Okay.
The first.
Okay, so let me stop sharing and just pinpoint to that so that you can see. I'll make it entire screens. Okay. 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 So now you can see my screen, right?
Yes, sir.
Good. So, as I was saying, so in this case, we can have a table. So we can have a table that we can call. Um, so we can have students, then we can have course, right? Then, so this is a table. Then we can have another table where we can say students. Then we can have sports, right? So over here, then we can have students was equal, and equal that's maths. Equal that's what we call science as well. Then, so let me just make this bold. So now the sports. So then we can have equal, and the sports we have what football. Then we can have equal. Then we can have tennis. Okay. I hope you can see the screen, right? Let me see
Yes,
the
sir.
screen. Good. So you see that see the difference. This one we're having about 1, 2, 3, 4 rows. But we were just having 2 rows here, and we're having 2 rows here. Right? Hello.
Yes, sir.
Yeah.
Good. So this is the thing. Now, in order to so if we're able to reduce this, that means we are even saving space. And usually what happens is that when we are doing all this because if you need an information and you want to retrieve the information, if you haven't normalized your table well, the tables well, in retrieving information, at times you might get some inconsistent data. At times too, there will be delay in the processing. See what we've done. We have the student course here where we can when we look for a QA, we search for a QA and want to do the course. It will give us a QA, it will give us math and science. That is very simple. But over here, if we look for a QA, it will give us all these things. So that means there will be a lot of duplicates. It will give you the math here, it will give you the science, you repeat another math and give you another science. And this one will give you all the sports, the sports here, football, tennis. Over here, once we query for this, it's going to give us this and these 2 courses. Likewise, if we query a query from here, to give us these 2. To make it more simpler and very fast. So that's about the 4th normalization. As I said, I'll look for the BCN, then okay, I'll even open your model and see what is there. So let's I think this is the last one. Let me finish this. Then I'll open your model. Then we'll look at I think there are some tables there. Wait, let me finish this. So
Okay.
where there's the takeaway, which is that table of relation table. You can also say relation. The organized collection of data. Then we have keys. We have the primary key, that is a unique identifier. We have the foreign key that links the table. Then the candidate, that's a potential primary key. And the constraint, we have the entity constraint referential, which we also call the foreign key, and the domain constraint. So domain is more about the data type. And also if we don't want to have a null thing in there. So to normalize, we usually move from the unnormalized form to first normal form. Then we move on to second normal form, third, and we go to the BCN form. And the more we normalize, the more we have less redundancy and better in integrity. So in normalizing the first normal form, we look for atomic values. We want only a single value. We don't want repeating groups. And the second, we don't want partial dependencies. We want full functional dependency. Then the third, we don't want transitive dependencies, ABC. We have to depend on B and B depend on C. Then we have the BCN. Every determinant is a candidate. Every determinant is a candidate. Then we have this. So let me see from the book. I think that will provide more. Let me see page, let's say 90. Let me see. Okay. You can read the model for more insights. So let me see the BNC, because usually at times you might have some. Okay, good. I want the table for you to understand that side. Okay. Let's see, what's this? Second. Okay. Okay. Um, okay, yeah. So I hope you can see my screen now. Can you see my screen?
Yes, sir.
Yes, sir.
Yes.
Okay. Okay. So a relation is in BCNF if and only if every determinant is a candidate key. A candidate key will mean a primary key or a unique key. So the idea here is that a table complies with BCNF if and only if it is in the three NF states. And for every functional dependency that is X maps to Y, X should be a super key of the table. So over here, we are giving the employees table. And employees table, we have the employee ID, employee nationality, employee department, department type, and a department number of employees within that department. Okay. So now let's see the function dependencies. So the function dependencies, we have what we call the ID. And this one, the nationality depends on the employee, nationality depends on the employee ID. Okay. Then we have the departments. So where you can see that we have number of the number of employees in the department. And this and this, even by keywords, we know department, department, departments. So it means that this and this can be under one table, because with a department, we're able to get a department type and the people working in that department. And over here, since we are seeing here employee ID and nationality, that means we could have an employee, a table that could have details of the employees. So over here, we can see that the super key here is what we call the employee ID, the super key here. Then the employee department also has what we call the type and the number of employees within that department. So to get the candidate keys, we combine the department, employee department, and that of the employee ID. That becomes the candidate key. But it says that, however, the table is not in BCN as either the EMP ID nor the EMP department alone are keys. Okay, so let's understand this. So to make the table conform to the BNC, first we have to break down the table into three tables, as they've done here. So you realize that the employee nationality, we have employee nationality table. So we have the employee ID and we have the employee nationality. So this will give us the employee and their nationality. Then the next table, we have the employee department table. So over here we can see that we have the employee departments and the department type and the number of people working in the departments. Then the last which is a Ghanaian, maps to the department production. Employee ID 2 maps to planning, the department planning, and the person is a Nigerian. So with the tables, with these tables, based on the previous table, we can see that although the functional dependencies remain the same, the candidate keys change. And this is below. It changed because right now we are having what we call the employee ID mapping up to being the same table with what we call the employee nationality. Then we can have the employee department also having the same thing with the the type and that of the number of employees within that department. So the candidates key is there. For first table, we have the employee ID. In the second table, we have the employee department. Then for the third table, we have the employee ID plus the employee departments. So I told you that basically the normalization is more of decomposing, breaking the table into various parts. So realize this one, we have three tables out of the main one that we have. This we're able to come up with three tables because we have to link them. So we'll link the employee ID with the nationality table. Then we also have to have an employee department table. Then over here, we'll link the two, the employee ID with the department, because it's something that is common. We have employee ID here. So using that, we're able to link the department together. Okay. So I'll just do my best to look for a tutorial on this. Then I'll put it in. My fear is that even when we give you materials to even listen, you don't have time. My other class, you give them, I've been giving them they'll be telling you, say, we work and we don't have time more and all that. So it's something, but all the time, I will just put it in there. Those who have time, they should just look at it and get understanding. So as I said earlier on, I think during the week, I'll try and create some quizzes out of the various units 1, 2, and 3. Then I'll put a link in there just for you to try to see your understanding of the subject matter. It will be there. So try as much as possible that you can, so that you can score a higher mark. And I'm just praying at least some questions should come in your quiz. Okay, please, any question? Somebody wanted to ask me a question. A lady wanted to ask me a question.
Yes, I'm here. I was asking, the way the fourth normal something, the F4NF and the one NF, is it not the same thing? Like, shouldn't we just do it like the way we do the one NF? Do you get it?
You
Like the
said
4NF,
the fourth
the
and the one are the
samples.
same.
No. Like the way the example of the fourth came, it's more or less like the first one. So why don't we just do it like the way we did the first one? I'm just
No, you
asking.
see, yeah, this is the thing. As you move up, you have to make sure that what is below you is the state before you can move up. So to move to 2, you have to ensure that you've done you are in the first normal form. You've done it before you can move to 2. So as you move on, you add up. But you need to make sure you fulfill what is below you. Okay.
The question, would it be specific that we should do it in the third normal form, the fourth normal form, and co? Like for examination purposes.
That one I can't,
Is it
but it can be possible. They can give a table and they can tell you to convert a table to a first normal form, or maybe to a third normal form.
Okay.
And if I'm supposed to convert to a third normal form, you have to first of all do the first normal, then you do the second, then you come to the third.
Really?
Oh,
Okay. Thank you very much, sir.
you're welcome. But I'll try my best to give you a tutorial, send you a link to explain more of them. Because once you understand it becomes part of you, you are done. Any question on it, you will solve.
Sir, please, we will listen. So please, you do well and send it for us.
Yeah, I'll do that. I'll do that. Those who will listen, fine. Those who won't, fine. I'll just do it for you.
All listen.
I'll give you all the units, like 1 to 3. I'll just put that for you. So are we okay?
Okay.
Yes.
Yes, please. Sir.
So I can ask questions.
Sir.
Yeah.
We learn you have created a new WhatsApp group.
You learned. You learned from where? Please, you learned from where?
Oh, sir,
Oh, you
from
learned
those
from
who
where?
participated in those who
From those
participated
who,
in last.
Me, I don't know anything about that.
Oh, say.
Yeah, I don't know anything about that.
Okay. Okay,
You are
so
telling
let
me,
me
yeah.
assume. Okay.
Okay. So let me see if we can do some small. I'm coming. Let's see if we can do some small tests. I mean, just to help us with our understanding. So I'll say normalization. Okay. Okay. So let me just share the screen again. Can you see the screen?
No, please.
You can see the screen.
Yes,
You
sir.
can
Yes.
see. Hey, madam, you always you can see you.
Yes, we can see.
We can,
It has come.
You can see.
yes,
Yes,
sir.
please.
So this one, just a minute. When I mention your name, then you answer. Okay.
Okay, sir.
Okay. So let me also come here. It's light out here. Okay. So patience. Patience.
Sir, I can't see the screen no.
Hey, patience. Ubwa.
Oh, I'm pa.
Are you Francisca?
Sir,
Read the question and answer.
dash is normalized after it has been organized.
Answer.
A table.
Do we all agree?
No, sir.
No.
The answer by Dale is a
No.
database. The answer
Who
by
said no,
Dale.
sir? The answer is there.
Do,
Even
Okay.
me
it's
see.
just true.
The answer is already there.
The answer is
Okay.
Dale.
So the
Tab
answer is
one
what?
database.
Database.
A table is normalized after it has been organized.
So you see the explanation. Database normalized after yes. Okay. Collins.
A database. Wow.
Collins.
Yes, sir.
Answer this number 2.
Okay, so by normalizing relations or sets. Sorry, I can't see clearly. I'm coming. By nominalizing relations or sets of relations, one minimizes redundancy.
Is it correct? Do you all agree?
Yes, sir.
Do you all agree?
Yes, sir.
Okay.
Yes, sir.
So let's see if it is correct. It's correct. Good one. So that's the explanation. By normalizing relations or set of relations, one minimize redundancy. That's correct. Okay. Felicia.
Sir.
Felicia.
Sir.
Answer this for us. Number 3. Felicia, then we'll move on to the next person. You know the seat up. Okay, Teresa. I don't know whether it's Teresa or Teresi. Teresi or Teresa. Okay, let's go to Frank. 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 Okay, let's go to Afsa. 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 Okay. Francisca.
Say.
Francisca. Answer this number 3.
Say.
Read number 3 and answer.
In addition to removing undesirable characteristics, normalization also eliminates anomalies.
What's the answer?
Update.
What's the answer?
Update.
Is she correct? Do you all agree?
All the above. All the above.
All the above.
Is D.
Is D.
All the
Yes.
So all the above.
Wow.
Okay, good. Okay. So Raphael. Raphael. Josephine. Jojo. Let's go.
Yes, sir. Yes, sir. Yes, sir.
Oh, you're the one who answered.
Yes, so say I've answered for somebody, so choose somebody else. This one.
Okay, Charlotte.
Sir, we are 2. We are 2. We are 2.
The Josephine, you are 2 or Charlotte?
Oh, Josephine is only 1.
Charlotte.
Charlotte is 2.
Charlotte, we are 2.
Charlotte. Okay, Charlotte 1. The one in white and black.
Hello, sir.
Please, I said Charlotte. Or you are Charlotte?
Oh, please, this Raphael.
I said Charlotte. So Charlotte, where is Charlotte? Charlotte, if you are not there, Yvonne. Okay, Charlotte 2, answer. Please, let's be fast so that we can do more. Let's be fast. Charlotte 2. Yvonne, let's go.
A common approach to normalize. Hello? A common approach to normalization is to the larger table into smaller tables and link them together by using relationship.
Hello, sir. Please, can you guys hear me?
Charlotte, please, we've passed you, so you're not around. You want to continue?
Is a
Why
a common approach
Yvonne,
to
Yvonne,
sir. Yes,
I told you
please.
normalization is all about one big table. We are dividing the table into smaller ones. So why do you say add?
Oh, then is D.
Where is divide?
D.
Normalization is all about dividing. That's why there was a big table. We're dividing them. We create another table out of it. So please don't forget.
Okay.
Okay, Charlotte, I'll give you another chance. Charlotte, let's go. Charlotte, let's go.
Hello.
Continue, number 5.
Redundancy is reduced in a database table by using the dash form.
What's the answer?
Normal
What's
form.
the answer? Okay, that's correct. Because we're mentioning it, normal form.
Hello?
First normal form, second normal form. If you had to wrong, I won't even understand you.
Hello, please, can you guys hear me?
We've heard you. You are done. You've answered it. Ameku.
Oh, okay.
Ameku. Ameku.
So let me answer that. So let me answer this
No,
one.
Ameku, let's go.
It's 4. Say it's 4. It's 4. Say it's 4.
Ameku. Okay, the answer is 4.
It's 4. What's the answer? It's 4.
Okay, Brenda.
Sir.
Brenda.
Sir.
Read the question and answer number 7.
Okay.
Please, all of you should mute your mic. Please, all of you should mute your mic. If I don't mention him, don't unmute. Mute your mic until I mention your name. Brenda, let's go.
Which of the following is not a type of normal form? Sir, is D.
D. 10.
Form is not a
Okay.
form of normal. Yes.
Okay, thank you. Obed. Obed, let's go. Obed. Yes, Obed.
So I'm here.
Yes, so answer number 8. Read and answer number 8.
Which of the following is a type of normal form? B, BCNF.
Good. So you see, you're all getting it correct. So that means that what I taught you really understood. So let's move on. Osei. 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 Okay, Stephen. Okay, Osei is up. Yeah, read number 9, answer.
When a relation contains an atomic value, it is a one normal form relation.
Good. That means you paid attention. Correct. Stephen. Okay. Then I'll move on. Jennifer. Jennifer, read number 10. Okay, Jenna, let's go. Jenna.
2 NF, yes, sir.
Number 10.
Yeah.
Go.
Two normal form relations are those that are in one NF with all the attribute types dependent on the key, on the primary key.
On the what?
Primary key, A.
Do you all agree? Do you all agree? Hey, my guys, do you all agree?
Yes,
So
sir.
let's say,
Yes,
guess
sir.
what? Let's see. So Gina is correct.
Yeah,
Joy
it's correct.
Harrison. Joy Harrison. Joy Harrison, let's go. Yusuf. Yusuf. Yusuf, let's go. Isaac. Isaac, if you are there, pick up. Isaac. Rashida. Rashida.
Sir.
Let's
Yes,
go.
sir.
Read number 11. Read number 11 and answer.
When a relation is in two normal forms and there is dash, it is in three normal forms. So the answer is A. So it's A.
Do we all agree? Do we all agree?
No, sir.
Yes.
No, sir.
You don't agree?
No, sir.
No.
Sir.
No, sir.
Sir, Isaac. Isaac. No, sir.
Okay, so Isaac,
Sir, the answer is B.
Transition dependent.
answer is what? It's what?
B.
Okay, let's see. So the answer is B. There should be no transition dependency. Okay. Now, confidence. Confidence.
Sir.
Okay, let's do number 12. Confidence, let's go.
A relation is in dash if it's in boys code normal form and it does not have any multi-valued dependency. A relation is in, I think the answer is D.
Okay. Do you all agree?
Yes.
Okay. Okay, Gifty. Gifty. Okay. Priscilla. Priscilla.
Sir.
Let's go. Number 13. Number 13. Let's go, Priscilla.
Okay. If a relationship has 4 NF and no joint dependency, and when it joins, it should be dash. It is consider 5 NF. Hey, answer.
You said what?
Say the answer. Somebody should help me.
Okay, mention somebody to help you. Mention the person's name.
Confidence.
Confidence. Yes, what confidence? So answer. Number 13. Confidence, you are there. We know you are there. Answer. Confidence, you have a girlfriend now. Answer. You have to bail her.
Yeah.
If you can't bail her, you get another man. Let's go, confidence.
If a relationship has a 4 NF and no joint dependency, and when it joins, it should be dash. It should be dash. It is considered Sir, it should be lesser. It should be B.
Do you agree?
No, sir.
No, sir.
This was saying no, sir. So what's the
Hey.
answer?
Sir, it's C.
Confidence.
Sir, the answer is C.
C. Confidence. You've I mean failed Priscilla. So let's see.
Priscilla.
It's C.
Yes,
The answer
sir.
is C.
Okay. Yeah,
Adams.
thank you.
Adams, let's go. Adams,
Sir,
let's go. Number 14.
why are you giving me wrong answers?
Read and let's go and answer. Adams.
What is true about the first national, the first normal form? A. The answer is A.
Answer is A. Read it and let me see.
If a resid contains an atomic value, it will be one normal form.
And you are saying the answer is A, right? Please, do you agree?
Yes.
No, sir. Hey.
Do you agree?
No, sir.
No, sir. Sir, it's B.
Sir, it's B.
You are saying it's B. Okay, what's the answer?
All the above. B.
Good.
Sir, B.
All the above. Because all that they're saying is all pointing to one thing. All the English. Okay. So let's go to Elisha. Elisha or Elisha. Let's go. Okay, if he's not there. Oh yeah. Oh yeah.
Hello, sir.
How are you?
By His grace. His the name is Oye.
Oh yeah.
Yes, please.
What does it mean? What does it mean?
It means good.
Oh, you can't tell us. Eh?
It means good.
It means good.
Yes, please.
So if I Google, oh yeah, I will know it's good. Eh? Where are you from?
It's a bad name.
Where?
Water. I'm a Botarian.
Oh, LK1.
I don't understand.
Shame on you. You answer 15 for me.
Okay, sir, please. I was offline. I just joined, so I will try.
If you can't, you can mention a boyfriend to answer for you.
I hear. So number 15, neither multi-valued nor composite attributes nor their combination may be used in the dash normal form. Neither. Says C.
Oh yeah, it says C. Please, do you all agree?
No.
No, sir. No, sir.
Hey, my boys. Oh yeah, Charlie. Choose
Sir.
one guy to answer for you. I think Adam
So
wants to help you.
The one who said
Adam
no.
wants to help you. Your brother wants to help you, Adam.
Sir, Adam is here.
So he was one of them.
Sir, the answer is
Adam.
The answer is A.
What's the answer?
Sir.
Speak louder.
Sir. The answer is A. First.
Rain is A.
A.
Yes.
Yes, sir.
Okay, let's see.
Okay.
Let's see. Okay, it's first. So your brother said you.
The answer is A.
Thank you.
Okay. Kingsford.
Hello.
Kingsford.
Are you fair?
Yes, sir.
Oh yeah, are you fair?
Please come
Oh yeah, your
again.
brother is asking whether you are fair. Are you fair?
I'm chocolate.
You are chocolate. Yay! I see. Happy
Does,
birthday
does,
in
color,
advance.
does color matter in answering these questions?
And
Oh,
ask
that's
again.
again,
No.
my brother.
Guess what? Let's go. I think the brother wanted to know.
No, it's
Brother
a
wanted to know.
question for what?
Thanks for
Use the chocolate for
Yeah,
banana.
sir.
No, the question for wife. All right.
thanks for number 16.
Okay, sir. What is true? What is true about the second normal form? Which is 2NF. Mm.
Thanks God. If you are teased, you can choose a
Sir,
girlfriend
I
to
think
answer.
it's. I see.
It's here. Is it correct?
No.
Yes, sir.
There is
So
no and
yes,
yes.
both A and B.
Okay, let's
It's
go.
A and B.
It's correct.
Yeah, A and B.
It's correct.
Yes, sir.
Let's go to Adam. Adam, let's go. Adam. Okay, Francis.
Yes, sir.
Francis. Answer this for us. 17.
Sir, I'm very serious. I don't know whether because of the location or
And
what.
we know your location. Anyway, I'm just going to
Please, I'm at.
put the link in your chat.
Okay.
Oh, okay. I'm putting the link in the chat. Just be trying them. Okay. Time is up.
Okay, sir.
Okay, sir.
Don't go
Please.
and put it in the WhatsApp group. Don't go and put the WhatsApp group. And over here, you can get a lot
All right,
of
sir.
so the site that I went to, you can use it to get a lot of multiple choice questions and solve. Okay.
Okay.
Yes, sir.
When you go there, you can search for a topic. You can put in the relational database. It will give you questions on that and just try your hands on it. Okay. So you can have database MCQs. Then you go there, then you choose DBMS. That's what we did. Then at DBMS, you have a lot of them. So look at the model and go and look for them. Just do it. If you master this, I mean, and with this, you can try any other courses that you are doing too. Okay.
Okay, sir.
So time is up. So we'll call it a day.
Sir.
Sir.
Thank you too.
Thank you all for your time.
Sir, please
Yeah, thank
send
you.
your
Yes.
questions on our platform for us.
Thank you very much.
Yeah, I'll do that. I'll do that. I'll
Thank
do
you
it
in
for you.
advance.
Yeah, thank you too. Okay.
Thank you, sir.
Bye-bye. And all the best in your quiz. All the best in your quiz. So we'll meet again.
Thank
We'll
you.
meet again for the unit 4, 5, 6 after your quiz. So all the best. Go and make me proud.
Okay.
Thank you, sir. We'll make you proud.
Go and make
Thank
me
you.
proud.
We'll
Okay.
make you proud, sir.
Sure. Okay. Bye.
Bye-bye.
Bye, sir.